Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the directory traversal module, titled File Path Traversal, Traversal Sequences Stripped Non-Recursively. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsrigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down again, select directory traversal, and then go down one last time to lab number 3 titled File Path Traversal, Traversal Sequences Stripped Non-Recursively. Alright, let's get started. This lab contains a file path traversal vulnerability in the display of product images. The application strips path traversal sequences from the user-supplied file name before using it. To solve the lab, retrieve the content of the etc passwd file. Okay, so our target goal over here is to exploit the path traversal vulnerability, which again has some kind of defense on it, and then retrieve the content of the passwd file. All right, let's get started. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being intercepted in my Burp proxy. So the first thing you should notice over here is just like with the other labs that we solved for the path traversal module, it has a request that retrieves images from the server that the application is hosted on. And so anytime you see like file name or where it could potentially be retrieving files from the server, you should definitely test it for path traversal and other vulnerabilities like LFI and RFI. So we're going to send this to repeater and try and test it in repeater. So if we hit send on the original request, you could see that it's a 200 OK message and it retrieves the content of the JPEG image. Now let's see if this is vulnerable to path traversal. So the first thing that I'm going to do is see if it accepts an absolute path. So etc passwd, hit send. And it says no such file. So the next thing that I'm going to do is see if maybe it only accepts, it only looks for that folder in the specific directory that I'm in. And so what we're going to do is use the path traversal sequence to get out of that directory. So we're going to say go one directory up, and then another directory up, and then another directory up, and then another directory up, and then look for the passwd file. Hit send. And that didn't work either. So now let's try another technique. And usually you just use a scanner that fuzzes your application with a bunch of payloads for path traversal, and Burp can do that. However, we're trying to do this manually first so that we understand how it works. So far we've tested this and it didn't work. We also tested this and it didn't work. So the next technique that I'm going to try is I'm going to see if the application is filtering the string from any path traversal sequence. So path traversal sequence is this right over here. So this tells it move up a directory. And so the developers might know that some people might exploit it to read files on the system. And so what the developers are going to do is they're going to say, if you find this specific string over here in any user supplied input, then remove it. So when we give the application this string, what it's going to do is it's going to remove this, and then it's going to remove this, and then it's going to remove this, and then it's going to remove this. And so what we end up with is this right over here, which we already know doesn't work. And so a way to bypass that is if they're not doing this check recursively, is we can add another dot dot and then a slash, and then add another dot dot and a slash for each one of them, and I'll explain why in a bit. And so if they're looking for this specific sequence, so if I'm a program and I'm looking for this specific sequence, you could see it's available over here, it's available over here, it's available over here, and it's available over here. And so it'll get removed in each instance. So the third one as well, and then the fourth one. And so if it's not done recursively again to check if there's any leftover strings, we do end up with our exploit, which is the original one that we did with just a very simple way to bypass that specific inadequate defense. So if we go back, this was our exploit, so we're going to copy it, put it in here, and hit send and see if that works. And here we go. So it allows us to view the content of the passwd file, which tells me that the developers are definitely non-recursively checking for this string and removing it. And I say non-recursively because if it was done recursively, that means you would have to, once it removes this string right over here for each instance of it, it'll go back and check if there's any more instances of this specific character sequence in the payload or in the user input that was given. Okay, so if we go back to the application and reload it, we should see the sign that we successfully completed the exercise. And we do. All right, so we successfully completed the exercise by exploiting the path traversal vulnerability manually. Now let's script it in Python. So just like the other labs, this should be relatively simple because it's an unauthenticated vulnerability and it's only done using one request. So the script is going to be relatively small. The first thing that we're going to do is import all the libraries that we want, which is the sys library, the requests library, the URL lib3 library. And then we're going to disable insecure request warnings. So URL lib3.disable warnings. URL lib3.exceptions.insecure request warning. And then we're going to set our proxy setting because we want all the requests that are made by our script to be sent to burp just in case we want to debug the script. So HTTP 127.0.0.1 and port 8080. And also HTTPS traffic gets sent to where burp is running, which is the same place, HTTP 127.0.0.1, and again, port 8080. All right, this looks good. Next, let's define our main method. So if name is equal to main, then run the main method, and we'll define the main method right over here. Now, in the main method, we want to ensure that the user ran the program correctly. So we're going to say if the length of the command line arguments is not equal to 2, then print the usage instructions, which is the name of the program and the URL. And we take the name of the program from the command line, so sys.argv and 0. Okay, and then we're going to print example instructions. So example, again, name of the program, and then an example URL. So let's say www.example.com. And again, we take the name of the program from the command line argument. And then we're going to say sys.exit -1 because we want to, since the user ran it incorrectly, we want to exit the script. All right, so it enters this if clause if the script is run incorrectly. Now let's assume the script is run correctly. First thing what we're going to do is create a variable called URL and then set it to the second command line argument. So argv1, and then we're going to print a statement saying that we're exploiting the directory. So the directory traversal vulnerability. And we'll do that using a function that we're going to create called directory traversal exploit. And that function is going to take in the URL of the application. All right, this looks good. Now let's define our function. So def directory traversal exploit, and it takes in the URL. The first thing that we're going to do is define the URL of the vulnerable path. So image URL, and that's going to be URL plus the path to the vulnerable function, which is this right over here. So we're going to copy all of that, including our exploit. And put it right over here. Next, it's as simple as performing the request. So requests dot get, and we say dot get because it is a get method. It takes in the image URL, which we just defined, set verified to be equal to false, and proxies to be equal to proxies because we want the request to be sent to burp. Now I want a way to verify that my request did work and my exploit did work. And so the way I'm going to do that is I'm going to say if a specific string is in the response of the request that I just made, then print a successful message. So the string that I'm going to look for is this right over here because this user will always be in the passwd file. So if this string is in the response of my request, that means my exploit worked. And so I'm going to print exploit successful. I'm also going to print the following is the content of the passwd file, and then we're going to dump the response of the text, which essentially is just going to dump this right over here, which is the content of the passwd file. Okay, now this is if my exploit worked. If my exploit did not work, then I'm going to print exploit failed, and I'm going to exit the program because my exploit failed. All right, this looks good. Let's review it. So we've got our main function, which first ensures that the user ran the program correctly. If the user did run it correctly, it'll call the function directory traversal exploit, which essentially performs this request over here and attempts to exploit the path traversal vulnerability. If we find this specific string over here in the response of our request, that means our exploit passed, and it'll dump the response of the exploit. If we don't find this string, that means our exploit failed and it'll end the program. All right, let's see if we have any errors in our script. So terminal, new terminal, and we're running directory traversal lab 03.py, and then the URL of the application, which likely timed out, and it did. So let's generate it again. Let's copy that, put it in here. And this did not copy right. Right, so let's remove all the extra characters and the trailing slash because that's going to interfere with our program, and run it. All right, so we do get an error and we misspelled that. So it's disable without an A. Let's clear it and run it again. And here we go. You could see over here, it said the exploit was successful and it dumps the content of the passwd file. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at a more complex case of path traversal vulnerabilities.